In this question, we have to explain the given terms with suitable examples. The first one is coagulation. Coagulation refers to the process of aggregating colloidal particles to produce larger clusters or precipitates which then separate from the dispersion medium. This usually occurs when a coagulating agent like an electrolyte is added to the colloidal solution. It will neutralize the charge on the colloidal particles and causing them to clump together. For example, we can say when an electrolyte like aluminum sulfate is added to colloidal suspension of clay in water, the clay particles coagulate and settle out of the solution. The second one is multimolecular colloid. A multimolecular colloid is a type of colloid in which the dispersed phase consists of aggregates or clusters of small molecules or atoms. These clusters form colloidal sized particles even though the individual molecules themselves may be much smaller. For example, a gold sol is a multimolecular colloid where individual gold atoms cluster together to produce large particles that are in colloidal range. The third one is gel. Gel is a type of colloidal system where a liquid is dispersed in a solid. It results a semi-solid or jelly-like substance. The solid network traps the liquid within its structure and giving the material a rigid yet flexible texture. Gelatin forms a gel when mixed with water and cooled in this system. Water is dispersed in a network of gelatin protein molecules. Now let's come to the OR question. Here it is given out of starch and ferric hydroxide salt, which one can easily be coagulated and why? The one which can be easily coagulated is ferric hydroxide because it is a lyophobic salt. The second one is what is observed when an emulsion is centrifuged. When an emulsion is undergoing centrifugation, de-emulsification will take place. The third one is what is the role of promoters and poisons in catalyst. Promoters increase the efficiency of catalyst whereas poison decreases the efficiency of catalyst. Both of them are having opposite roles in a catalysis reaction.